Hey everyone, I'm Nick Matthews. I'm a principal product manager on the VPC team. So I lead AWS Cloud WAN, which is what we'll be talking about a lot today. And so we're going to talk about doing a wide area network. This is AWS, so some people know what that is, some people don't. I think you guys probably all do, but wide area network is just a long network. So if you strung a Cat5 cable across the country, that'd technically be a wide area network. And AWS has put a lot of cable, a lot of fiber into the ground. And how would you go about using that if you were going to try to build a wide area network? So we're actually going to start here with a little bit of a history lesson. So I've been here for a little over 6 years doing these types of presentations. And I've actually started to see some of the same patterns that happened 6 years ago, and beyond, start happening again, even though we've built a lot of new things to solve those old problems. And so if you go back in sort of history, right, virtual private cloud, VPC, is one of our favorite things. We've got customers with thousands of these things, but there was a time where we thought customers just needed one, and we just called it a virtual data center. And so we said, hey, look, if we have the correct IAM and the correct security group type things, you can put hundreds or thousands of different types of customers and your business units in the same VPC. And we've got people that do that. And we thought that was how people should build the cloud. And then I think what happened is we did more enterprise type stuff. If you're a company, you're probably more used to saying, hey, someone wants to build a new app, so we're gonna give them a subnet off the firewall or a /24, and then that's their kind of playground for them to do networking things. And then that kind of maps more closely to like an AWS account. And so we found customers wanted to have lots and lots and lots of different AWS accounts because they didn't want people to have to share accounts, either for billing reasons or security reasons or whatnot, which also means they get lots and lots of VPCs. And so customers were doing this whole transit VPC thing where they were using our own VPN service in combination with some EC2 instances running routers. And as you can see here, there's lots and lots of lines, 2 VPN connections for every single VPC. But you do get this kind of pretty thing at the bottom where you get one set of VPNs and direct connects at the bottom, which is what everyone wanted. Because no one wants to set up a whole nother 2 or 4 VPNs every time they create a new VPC. And so we took that feedback, listened, and 4 years ago or so, we created Transit Gateway. So that was like the native version of doing Transit VPC. And so there's a lot of cloudy goodness in this, right? So it scales horizontally. You can go up to 50 gigs of bandwidth, thousands of attachments, and you still get the sort of pretty VPN and direct connect consolidation at the bottom. And so this has been a super popular architecture and is the way that customers, this reference architecture that I actually built in 2018 still holds up, and a lot of customers are doing this. But we're seeing some things that kind of go back to the problems we had with Transit VPC. So I can expand on that a little bit. So essentially, if we take a look, we kind of start from scratch. What a lot of customers have is they have a data center with some dusty, crusty servers, and then connecting to VPN or direct connect to a transit gateway and a couple VPCs. This does all the stuff we want it to do, but then there's some other things we probably want too. So for example, as we start moving these servers up, going from dusty, crusty to magic EC2 instances, then what happens is maybe someone sets up a control tower, or they want 20 or 30 more VPCs, or 20 or 30, 40 more accounts, or more dev, test, prod type environments. You have more VPCs. Each of these VPCs, you need to create a route, create an association, propagate it to the other route tables, and there's some sort of manual clicking involved. So a lot of people end up looking at things like network automation. And so, how would you actually build this with automation? Well, you can do some of it with CloudFormation and Terraform, but we just end up seeing a lot of customers build, like, for example, Lambda code to automatically accept attachments or automatically propagate as they come on. And so it's one of the things these customers having to do in this situation. The other thing is now we get some more instances, get the data center moved out. A lot of times people end up going multi-region, either for disaster recovery or because maybe they have a company and some people in a different area, or maybe their users are there, and they have to go multi-region. So they create a peering connection between their transit gateway. Again, more sort of manual inputting of routes and trying to make sure that all the routes on the left and all the routes on the right get sort of summarized and sent to the right spots. Just a lot of work, to be honest. Security tends to be another one. So often when we see customers start off in this model, they will keep the security in their data center. So they'll send all the internet traffic from AWS, go through a data center, back into their sort of trusted, loving, warm and fuzzy security stack, because the security people know it and compliance people know it, and there's 300 checkboxes you need, and you can check them all on premises. But you find out that like, hey, I have a machine learning workload sending in stuff to another thing in AWS, and it needs to use a public endpoint. So we're sending like all this machine data and user data and bulk data back down through our skinny VPN or Direct Connect pipe out the internet and then back up to AWS again. That doesn't make any sense. But security likes it. So the concept is, hey, let's take that security stack and let's move it into AWS. The internet's still scary. We'll still have that security stack, but it will just look differently. It'll be built on cloud native security constructs, which hopefully you've heard a lot about this week in other sessions. The other one then ends up becoming kind of this extensibility. You're running, you're doing well on your network, and someone throws a wrench at you, and now you have another company that you need to worry about. Or maybe it's the development group that doesn't follow IT standards and doesn't have full control of it. And so how do you handle that? So now it's like, all right, well, we need to peer their transit gateway into ours, we need to get more VPN connections, and we're starting to get a lot of lines here again, right? A lot of things that we need to manage and sort of click around for. And then you have this other thing like, all right, well, now my data center is almost empty. How would I create, what do I do with my WAN? I've home runned everything to that data center, but now I need to get all that into AWS as well. I've got business partners, or I've got the WAN. There's other things that look like clouds, and got to connect that somehow. How would we make that work? And so this is kind of the rough agenda, because we're going to take this mess and kind of turn it into this, which is, let's put Cloud WAN in the middle of this thing. And so figure out how would we simplify these sort of more complicated and more sort of intricate designs into something simple. And so, some of the things with Cloud WAN, for example, is it's global, it's got built-in automation, there's built-in segmentation, there's interoperability with Transit Gateway. It also supports dynamic routing. So it's going to fix and work with a lot of those problems we were talking about. So if we dive in real quick, I'll sort of go piece by piece and show you how this stuff works. So essentially, we start off with regions. Cloud WAN is a global networking service, which means it will run across those regions. You don't have to do each one region by region like you do with Transit Gateway. So you start off with this concept of a global network. The global network is an existing thing. We launched that a couple of years ago as part of Network Manager. And it's basically the container right now, at least how it's being used, is for transit gateways. So you could register your transit gateway as part of a global network, and then you can go into the Network Manager console and see all your sort of pretty things, topology graphs, metrics, logs, and it's mostly a visibility tool. So with Cloud WAN, what we've done is we've added a whole new portion to the global network called a core network. So this core network is kind of the demarcation line of where AWS takes more of a hands-on approach to this routing concept as opposed to TGWs. But since it's still within the same global network sort of container, we can essentially look and manage both of them simultaneously. And so the core network underneath the hood is running something called a core network edge. There's one of those per region. It's essentially, you can think of it like a TGW, except for you don't have API access to it. From there, you create attachments, much like you would with Transit Gateway. So VPC, VPN, Connect for SD-WAN, and then you attach all those things to your core network in the regions you've selected. From there, you can also now, so we went GA 2 weeks ago in New York. You can now attach a Transit Gateway to Cloud WAN, which means if you have existing VPCs or an existing Direct Connect, anything of those types of things, you can attach your Transit Gateway to Cloud WAN, and then now all that's going to sort of flow through. And then underneath this is a new concept called Core Network Policy. So Core Network Policy is essentially a single JSON document that represents the intent of your network. And so you build this JSON document out, or click around the console. You don't have to be good with JSON. And it builds the configuration out. That configuration has a few different parts. One of them defines, for example, the segments. So the segments tell you basically your layer 3 isolated routing domains. And then segment actions, like what should happen between these segments, which is primarily routing. Should we share routes? Should we end static routes? And then there are attachment policies. So essentially what we've done is we've automated the way that attachments map to segments. And the primary way to do that is through tags. So essentially, as you create an attachment, you give it a tag, and that tag is now going to map it to a segment. So you don't have to manually take attachments and push them on a segment or anything like that. It's all sort of, that's the automation we've built in. Cool. So as opposed to me going through and telling you all the things we can do, I'm going to turn this into a bit of a story here. We'll see how this goes. So how many of you are like networking people? How many of you are like security people? How many of you are like developer people? Okay, so we've had some identity crises, I think, here. I think there's a lot of overlap, but that pretty much covers everyone, I think. And so the idea is you as a network cloud security type person, and all the people that bug you for network stuff and security stuff and what they want, and sort of how this sort of builds through in a semi-realistic kind of scenario. So you get this. You're sitting around doing your job, and someone builds out this giant proposal. Maybe it's got an official IT project and code name associated with it to build a brand new sort of self-service thing on the cloud. The developers are running 1,000,000 miles an hour, which is great. You want them to do that, but someone's got to sort of tame that and keep control of it and sort of keep it in governance, but also move fast. At Amazon, this is probably what we would get. We would probably get this document. The probably most unrealistic portion of this presentation is the fact that someone's going to clearly give you requirements. So I'm going to show you, we're going to slowly lower that quality of requirements you're getting over time so it becomes more realistic. But so the idea is, yeah, the developers are moving fast and we need to build a new cloud environment to handle this. So we start off is we're going to create a single region. We create that global network in Network Manager. We create the core network. And so we have to design the policy. We have to figure out what our intent's going to look like. And then we're going to apply the policy, and it's going to create the network for us. So the first step is really defining that network intent. That's the hard part for a lot of folks, which is, in this case, like, I've presented on this before. You can figure out how you want to split your environment up. We see pretty commonly that people use the software development lifecycle to do this. So production, development, staging. This could very easily be, client 1, client 2, client 3, or, oil, water, rock, earth, sun, whatever, or finance, HR, IT. But you figure out sort of your communication matrix here. So what you have to figure out is basically 4 main things. One is the network configuration. So which regions you want to be in, which ASNs you want to use in those cases. We will automatically deploy the ASNs, or you can manually choose it per region if you want. The segments, they have names. They also have some defaults we'll talk about, like should things be automatically accepted or not? What's the behavior of 2 things attached to the same segment? Some things like that. The routing, and essentially kind of defining this green and red matrix here, as well as how that attachment should work. So what tags do we want to use to map things to these segments? And so this all basically becomes your network policy. So in the case for this self-service IT thing, we're going to start here. We're going to do production, development, and hybrid. Mostly because PowerPoint doesn't have that many room for like a bunch of segments, and that makes my life a little bit easier, and hopefully makes it a little bit easier to follow too. So production, so essentially we're going to start off in one region. We're going to use US East 2. It's like Virginia, but just not Virginia. And we might need to go to more regions, but the requirements document didn't say anything about that. We're going to do the SDLC, software development lifecycle type thing. We do want development to be on demand, so we're not going to require any approval for developers to get into the development segment. And development can talk within development because we're not sure what they may need to do there. The routing, we're going to share routes from the hybrid segment to development and production. Production shouldn't be able to talk to production because we don't want something to happen there. And then we're going to use a very boring example here. If you put the tag of segment development or segment production or segment hybrid in, we're just going to map that directly to the name of the segment here. And so this is all our new network policy. If you're curious what the actual JSON looks like, it looks like this. So I've kind of highlighted in green, like kind of the key areas that are not just sort of brackets. You might notice over there on the right in the attachment policies, we basically say, hey, if the segment tag exists, then we're going to use the value tag of that and look for a segment with that name. So even if we had 20 segments, we only need that one policy because then it just uses the name that we're using in the tag. You can also go hard code this. You can also go use the VPC ID or account ID. So there's a lot of different ways to handle that. And so now we've built our policy. We've applied it to the core network. We've built it out. So now what we're going to do to get this out to the rest of our organization, we're going to use Resource Access Manager, or RAM. And so I can walk you through a little bit what that looks like. So essentially, you have your Cloud WAN / your core network. In the console, it's actually called a core network. That's using your Cloud WAN admin account. So that's typically your network engineering account, maybe with Direct Connect in it, or maybe with other Transit Gateway and networking kind of stuff. And then you share that out with the AWS organization. You can also share it out with individual account IDs or just your whole organization. But it is limited to one organization. And so those accounts now will be able to see a core network and be able to go ask and attach to it. And so when they have their VPCs and other things, you can go create those cross-account attachment requests. So we share it with core network. Just organizationally, we need to let users know they can do this somehow. So there's a couple tricks, like for instance, you could put like a little wiki in the description of the core network so they can go look that up and find out what tags and what things are supported. So now you start creating attachments. You create attachments and you tag those. They start attaching to the network. You also then, if it's a VPC, you're going to want to go and insert a route into the VPC route tables, into the correct subnets. So a lot of people will do, in this case, if the internet is on premises, like in here, they'll put a 0-0 route that points to the core network interface. And so that's most of it, right? So you've now built sort of a self-service network and relatively low amount of effort here. So what happens next? You're doing actual work and someone puts a meeting on your calendar, something, we need to get into EU, you don't know what's going on. Eventually you find out that, hey, we have like legal requirements to be into Germany, and Germany doesn't want to be treated like the rest of the world, so we need a specific set of our applications in Germany. Okay. So if you want to see what this looks like in JSON, all you do is add one line here. So in the edge locations list, you just add the EU central one, which is Frankfurt. And now we're going to go automatically and replicate everything you've done for the rest of this policy into Frankfurt. And so in the console, it just looks like this. You would pick another edge location, create your policy, and apply your policy. And now your network is extended to another region. And so, like you said, yeah, you edit the policy, you apply the policy, and then once the policy is applied, it takes maybe sometimes 10 minutes to go to another region. Under the hood, we're creating a whole new core network edge, and we're doing peering connections, and we're enabling dynamic routing on all these things, just for that one line of configuration that you did. From there, you get another meeting, another surprise meeting. You don't know sure what this is about, but now legal found out that we're in Germany, and they're very concerned that we're not meeting some laws and compliance over there, and they want to really lock stuff down. And so you find out that they want to make sure that this segment only ever exists in Germany, and that it can never talk outside of Germany. But from a networking perspective, you still want to manage it all as one big network. So what you can do is there's a couple segment settings that you can go change here. So in this case, we're going to actually, you can change which edge locations the segment runs in. By default, it runs in all segments, or in all regions. So we're going to specifically limit it to just Germany. And then here, it also says like which segments is allowed to talk to. So by default, you can do some very permissive, kind of easy ways to say like, I want hybrid to talk to everyone. Well then, you don't want hybrid talking to Frankfurt because they don't want to talk to anyone else. So you can really lock that down to deny a specific list or allow a specific list of segments. So compliance people are pretty happy about this. If we take a look at what this looks like now, we've got a Frankfurt region, but we're going to create that specific segment just for the EU. And it's going to live just in Germany, which for us is 65,002 is the ASN. Cool, so doing well so far. All right, now we get a page. We're eating lunch, doing more work, and production's down. Sam, it's always Sam. You knew they were going to push a change today, and well, it brought the network down. This is no bueno, which is Spanish for outage. So now people want to know how like the network works, because it didn't work for a while, so now everyone wants to know the details. So the way the changes actually happen in Cloud WAN is a two-step process. So first is you create the network policy. There's an API for this. Once you create that API and submit it to us, or either the console or API, however you want to do it, we're going to validate it's valid and the JSON's good and the rules are right and that kind of stuff. But then we're going to generate a change set. So this is a concept we borrowed from CloudFormation, where we're going to tell you what's different in the network. We can say that you're going to have more regions or less regions, or some segments are going to appear, or some of your attachments are going to move to someplace else based upon some new tag change. So we can give you an idea of the topology change that's going to happen, as well as you can actually go and see, like in a Git style diff, of what the actual changes look like. And so from there, once that looks good and yeah, it looks like what I expected, you can execute the policy. Once the execute policy, Network Manager is going to roll that change out to all the places where it needs to go. And we added some features recently to show you what's going on, so you can get a couple steps, so you can see what's going on, how long it took, that kind of thing. And so now when you go back to tell people how this stuff works, you can make some changes. So you can say, for example, we're going to create a new role for Sam, and he only has access to the core network create function. And then we're going to go, before we're making these changes, we're going to run this stuff through a change review board or a cab, because those are really fun. But it helps with compliance and not making mistakes. So the cab can review changes. And then we're going to create another role for the more senior admins that know how this process should work. And they're the only ones that can execute the policy. So now we can let the new people create policies, but the sort of trusted people actually go put those on. And you could time bound that and all types of other things that works with IAM. And so, what's also going to happen is at Amazon, what we do is called a correction of error, or COE, which basically means like we're going to ask a whole bunch of questions like why, and then we're going to come up with what we call like mechanisms, which are like, if you think about this whole team, if you replace the whole team with a whole new set of people and only had processes and procedures to fix this problem, what would that look like? Because if you go, well, Bob is supposed to look after Sam, so we're just going to ask Bob to look after Sam better. Like, that doesn't work. That's called best intentions, at least what we call it. So that's not going to work. And so usually your operations person is going to be like, how do we make sure this stuff's working properly? So one of the good parts of Network Manager, and this is, like I said, what we originally built it for, was to give you that sort of level of visibility. And so you can come in here, you can show like which regions you're in, where you're at. You can see, for example, the topology and how the routing and the segments and the attachments are all related to each other. You can come in and get events. So this is all an event bridge. So for example, if you wanted to create a Slack room that has every single BGP change or tag change or network change going on, you can get all that here. You can take all that and you can feed it into a pager or into a web page or whatever. It's just events. That's what Event Bridge does really well. And then you also have some more of the dashboards and graphs. So if you want to, for example, put up a pretty graph so your NOC looks like they know what they're doing, so that IT managers believe why they're spending all this money, there's a graph for that. And also more of a logical graph if you need to get into more of the troubleshooting or the architecture and design kind of side of things. There's some pretty graphs there for you to use. Cool. Well, things are going pretty well. Now you get another email. Now you get an email that says, hey, the pen testers, they're deploying WordPress with some unpatched plugins or something like that out there, which doesn't last for very long on the internet when it's not patched. And they've also found out they've moved laterally from that one WordPress server to something else. So this is also no bueno, which means we got hacked. So one of the things you can do here, this one's pretty simple. You can go in here into the development segment, because again, we weren't approving or being in this workflow at all. So we just let anyone join the development segment if they use the right tags, which is cool, a little dangerous. So we can reduce the danger here by creating this isolated attachments mode. This means we can let hundreds or thousands of developers onto the same segment and they can't talk to each other. Much like if you're at a conference and you're on the access points for wireless, I can't go and ping and SSH someone else's computer on the same wireless network because they block that sort of local control. So it's basically the same thing, but for VPC and attachment type routing. So that's pretty good. because that was a quick fix. So what this looks like is, in this case, I have multi-region, but it could be in the same region, which means these two VPCs on development now can't talk to each other. So I'll put this little lock icon next to development so I know what that means now. It's also good for sandboxes, good for production, where production apps don't need direct access to each other. Any place where you're doing auto-accept attachments, because you have no idea what the potentially are in those. Or we'll talk about this later, also if you want to connect a bunch of external networks that you don't necessarily trust, you can do that as well. What if you don't know if this is a good idea or not? How do you know that I can just remove all this access? One way is you can do flow logs. So flow logs show you the IP address and VPC IDs of flows. So you can go in there and all your VPCs, enable this that you care about, and then run it through Athena or some other query languages to find out if you have anything going on there. We also just enabled on Transit Gateway last week the ability to turn flow logs on for a whole TGW. So that's a new feature you can use if you're already using TGWs and it's new. You can also check for security groups for access that you've explicitly allowed, as well as VPC access analyzers, a fairly new tool that will let you go in there and query, like, can this talk to this? Can this talk to this? And like give you alerts and that kind of thing. You can automate it. There's APIs. It's pretty cool. So if you're not aware of it, it's worth checking out. All right, so things are going well. Security was impressed by the fact that you just fixed the developer issue pretty fast. And now the contracts are up for all the on-prem security gear. They don't really want to spend, I guess, $1.2 million on super GBICs. And so they want to move this to the cloud somehow and have come to you to figure out what this looks like. So this is not a real spreadsheet, by the way, but it's indicative. So essentially what they want to do is they want to take this internet access that's down here off the VPN, and they want to move it into the cloud. And so how does that work? Typically what that happens is you put the firewalls into a VPC, call it like a buffer VPC or inspection VPC, put a word on it. To the actual Cloud WAN network, it just looks like a VPC attachment. So what we're really doing here is we're doing some kind of fancy routing and fancy type of ordering of routes rules to make this happen in this way. If you're on this sort of journey, you're probably going to look at a whole bunch of other services. So Gateway Load Balancer and AWS Network Firewall are the types of things you'd put as inspection VPC. But you've also got things like GuardDuty, Amazon Detective, and AWS Security Hub, which are a little more sort of cloud native ways to look at your whole VPC environment. And so you'd probably want to use these things in conjunction. So the real short story is like, yes, the firewall stack you have on premises meets 100 different checkboxes. And when you move that into AWS, you're going to have to change how you meet those checkboxes, usually in a couple of different ways. And so you can basically combine a lot of AWS native services. Plus, if you want to, you can just bring your favorite favorite firewall vendor up into AWS and do that. Go a little bit deeper on that one to give you a little better idea of that magic routing I was talking about. It looks something like this. So in this example, in your core network, either you create a separate firewall segment or you just use the hybrid segment and attach a new VPC to that. In that VPC, in this example, I'm using 2 different availability zones. So I'd split that into 4 subnets. One for my core network attachments and one for the firewalls. If you have a gateway load balancer involved, you might have a little bit more in here. Or if you're using some of the new firewalls as a service, like Palo Alto has one that drops endpoints in your VPC, that looks a little bit different. So this is kind of a generic version of this. But the idea is you create that VPC, you attach it to Cloud WAN, and then you create segment actions. So you would basically make sure that the hybrid network is sharing its routes with development and production. And then within development and production, for example, if you want to do centralized network egress, you'd put a 0-0 route, static 0-0 route through the segment actions in those segments. And that would forward all the traffic through the firewall. And so depending upon your architecture here, this design is going to shift a little bit. We have some good blogs. Most of the stuff that you do with Transit Gateway is going to sort of apply one-to-one here. So yeah, this will just depend a little bit. You can talk to AWS and we can help you out with that if you get sort of stuck on it. Cool. All right, well, things are going well. You have security and internet in the cloud, and now you're minding your business, eating cereal on your kitchen counter, and reading tweets for the day before you do some actual work. And you find out from Twitter that your company is buying another company. And you didn't know it, no one talked to you because you're not, I guess, high enough or important enough to know about these things. But like this is going to roll your way. because they're going to need network stuff at some point. So over the next couple of weeks, you get clued in, you find out more about the startup. The startup's cool. They're making a bunch of money. They're so cool, your company doesn't want to mess with them. Like, don't mess with what's working with them. Like that, we don't want to turn them into us. We want them to continue being cool for a while. We'll ruin them later, but for now, they'll be cool. And so you find out from their networking folks, they've got a transit gateway with, some VPCs. So it kind of looks like your architecture, but it's not your architecture. And they don't want your standards. This is kind of like the cowboy scenario. You might even have these people working in your company that just don't like IT. And maybe you don't have to acquire someone to have cowboys in your company. But this is pretty standard. We see this all the time. Don't feel bad if this happens to you. This is very normal. So the way this works is they have an existing transit gateway. Luckily, for the ease of PowerPoint magic, they're in one of the regions we're already using. And it doesn't matter if they are, actually. It just makes my PowerPoint more complicated. So in this case, what we can do is we can attach their transit gateway to the Cloud WAN. We can attach it multiple times. So some of their traffic goes to one place, some of them goes to another place. Luckily, because they watch all these same Reinforce and reInvent presentations, they've also chosen to use development and production for their route tables. So it actually maps very cleanly to our architecture. And so in this case, you map transit gateway to a couple different segments here. Their VPCs. And so now you can think about, instead of these VPCs attaching directly to Cloud WAN, they just transitively map through transit gateway. And so the use cases for this are a couple different things. Like, one is we see this interop use case. Hey, someone has a TGW, you want to work with it. We also see these like migrations and brownfields. And then we also see sort of like this like federation type case, which I'll talk in a little bit more depth here. So the way this actually works is like this. So transit gateway, Cloud WAN, you create a peer. This is a little bit different. If you're familiar with like VPC peering and transit gateway peering, once you do a peer with those services, like you can start routing stuff. It's not the case with Cloud WAN. When you peer this is kind of like a trunk in the old layer 2 switching world. This just opens up a relationship between the transit gateway and the Cloud WAN. And so what's actually happening underneath the hood here is we're going into your transit gateway and we're doing some things. So we're enabling dynamic routing. We're creating something that's called a policy table, which allows us to do this, keep segments mapped. So we're actually doing some policy stuff underneath the hood. You don't have to worry about that stuff because it's network magic, but it is there, and it's pretty cool. It also means this is how you can enable dynamic routing on your transit gateway today by using this feature. And so next what you do is you create route table attachments. So these are attachments just like every other attachment we have. It follows the same rules and the same automation that we built earlier, which means that if you want these attachments to actually map to something, you have to tag them. So you tag these route table attachments. And then after that, that's when the BGP and all that sort of stuff is functioning. And so this allows you can do many-to-one or one-to-one or whatever you want to do on your route tables here. If you only have one route table and you run a flat network, that's cool too. You don't have to use segments at all. So if, for example, you said, hey, look, I don't want to maintain 2 networks because that's expensive and time consuming, and I don't want to talk to auditors about 2 different sets of solutions, and like, I only want 1 set of Terraform code or whatever, you can migrate. And so what that looks like is you've got inside your VPCs, you have that 0,0 route pointing to your TGW network interface. What this would look like is you would attach your VPCs to Cloud WAN. You would have both of those live at any given point. You test it, or sorry, you move the route table over, and now you can start testing. You could do this for just a single /32 route or whatever you want to do. You could test all this stuff out, and if this doesn't work and something goes wrong, you just change that route back, and you're back on transit gateway again. Once you feel comfortable and happy with all these things, you can then take away some of the old stuff. So you can take away the peerings and attachments. You could take away the whole transit gateway if you want to, if you don't need it anymore. And so you can do a full migration sort of like that. All right, well, we thought we were doing pretty well with this whole startup thing. We find out this startup has made some very bad decisions. And they're using some other thing that looks like a cloud, some other thing. I couldn't find any sort of diagram for other clouds in our architecture diagram library for some reason, so I had to hand draw this one. And I also made sure the kerning was incorrect. That way the branding doesn't look the same as ours, just so no one gets confused at all. So this is now our official other cloud symbol. And so now we have to figure out how to deal with this. So in this case, the other clouds over here somewhere, one of the things we can do is we can create a VPN directly there. Because IPsec is a standard and is pretty well established across lots of places. And because about a year ago, AWS built a feature called IKE initiation, which allows us to initiate a VPN connection to somewhere else. This allows us to interoperate with a bunch of other VPN services. And so not all the other VPN services act exactly like ours and use this same sort of like 2 tunnels with 169.254 addressing, all these kind of things. So in a lot of cases, once you interoperate, you'll only get one of those tunnels running, but maybe you create 2 VPN connections. And a lot of the other folks don't support equal cost multipath, ECMP. So usually you're limited to like 1 tunnel at about 1 gig, 1.2 gigs or so. But for a lot of cases, like maybe authentication is just hanging out over there, you don't need a lot of intensive data and whatnot. You just need basic connectivity. So VPN is a great option for that. Otherwise, if you say like, hey, actually we need to run like 10 gigs of stuff to this other place, you can use Direct Connect. So right now, Cloud WAN doesn't have a native Direct Connect attachment. We're just transitively using it through Transit Gateway. So we're getting a lot of use out of the transit word on TGW here. And so you can do Direct Connect down to your Direct Connect point of presence. There's a whole bunch of partners that will basically connect you to every other cloud's sort of Direct Connect equivalent. And then you can just basically hairpin through them to get there. You could also just use the internet. I mean, if it's cloud native enough and it's got encryption and it's got authorization and security on it, then you may not need to create a private network at all. There's also a whole bunch of SD-WAN sort of solutions here that will run wherever you want them to and all connect together. So now your call center person who you text every now and then, and you mostly get bad news from, tells you that, hey, the voice quality in Singapore is not good. They've got VPNs to Singapore and they flap and the quality's not great. We need to fix it. So essentially what we're going to do here is we're going to add another region, which I showed you how to do earlier. But now what we're going to do is we're not going to create any VPCs in that region. We're just going to create a VPN connection. So basically our core network is now in 3 regions. And now the site in Singapore can do a VPN connection within Singapore to the Singapore region. Luckily, Singapore is not a very big geographical place, so the internet connectivity from Singapore within Singapore is pretty good. And then it's going to run over the AWS backbone all the way into Germany or United States or wherever we want to go. And so we can use that high quality network without having to go procure a whole bunch of third-party contracts or whatnot over there. And so now our voice quality people are pretty happy, and that makes us happy. Your CFO now asks you a question. He's sending us over RFC 1149. For those of you that aren't into 20-year-old networking jokes, that's IP over avian carriers. So this goose, I put this in like pretty much all my presentations because people leave feedback all the time of like they want more goose. So I'm always looking for more ways to insert more goose. You can if you leave feedback, maybe I'll do something different next time. Either way, this goose delivers a message to you. And it says like, hey, our data center is looking pretty lame. All the apps are out of it. And the only thing left are your stupid network racks. Get them out. I want to close that contract out. And so, all right, well, let's figure out what that looks like. So what's actually left in your data center after you've done a huge migration? You've got the WAN and your WAN routers connecting to MPLS and whatnot. You've got maybe a connection to another data center, some dark fiber that you used to run storage synchronization over. Maybe you've got, maybe you do have this sort of extranet where you have VPNs and maybe even direct fiber out to some business partners of sorts. And then, we're still going through the whole pandemic thing. So people are still coming in via VPN and client VPN. And so, yeah, we're still treating the data center like it's the center of our gravity, even though most of the stuff's gone up to AWS. And so we want to shift that. How do we shift all that into AWS now that AWS is the new center of gravity for us? So the way this looks like is a couple different things we can do here. So we can take the VPN for the branches. So maybe they need MPLS, maybe they don't. We can come in over VPN. If they do want to keep MPLS, we can use Direct Connect. and we can keep that coming in. Maybe you've got some sites where you're doing a bake-off or some testing of SD-WAN. A lot of customers I've talked to are looking into SD-WAN, or they have plans for it, or they're still in the initial sort of phases of rollout of it. And so you can have a mix of both. You can have some VPN, some SD-WAN. If you have some old sites that you don't want to maybe put a new SD-WAN box in, you can have a mix. Or you can be fully SD-WAN if you want. So we can handle sort of either scenario. And then, like I said, if you want to do Direct Connect into the cloud, you can, but there's also a new feature called SiteLink. So if you have two ports, like in the case, the slide before, where we have two data centers that both have Direct Connect to AWS, if those two data centers need to talk to each other, you can use SiteLink. You just basically enable a flag on your Direct Connect port on the virtual interface that says enable SiteLink. And if two ports on the same Direct Connect gateway enable that, you can send traffic directly between those data centers without ever hitting an AWS region. So you're just using our fiber to get between two locations. And so if you need that sort of like faster bandwidth and you already have Direct Connect ports, it makes a ton of sense. And then, yeah, we can do client VPN as well. So we have a native service that you can map into this, or you can use your third-party solution if you want. Pretty much all of them have some sort of virtual AMI that you can load up, put it in a VPC, point the routes similar to the firewall situation. You put it in a VPC, put some static routes pointing at each other, and you can get your client VPN all into this as well. Which that's handy for client VPN, because now like, hey, we need client VPNs in India, we need them in South Africa, we need them in Dubai, we need them wherever. You can create those endpoints all over the world very quickly. So the other case that we see sometimes is more about like, okay, so all of the stuff we own is out of the data center now, but what of all those business partners we connected to and that extranet and those VPNs? How does that work with Cloud WAN? And I've gotten this question actually pretty regularly since we launched. And every customer approaches me being like, are we allowed to do this? Is this something that can work? Is this something you guys want to do? The answer is yeah, I think we actually have a pretty good model for it. I think one of the interesting things about these networks is you can't control how other companies want to contact you. They have their own HQs and their own resources and their own locations. And they may be all over the world. You can't force them into the regions that just you operate in. And so you can use Cloud WAN to sort of extend these networks to wherever they want to be. But you still get one management and sort of control plane. And so, yeah, it's kind of the same case as we just talked about with the branch offices. They want to come in over VPN? Great, that's easy. Direct Connect, SD-WAN, also. What we've also seen is some customers that go, hey, we're using this as our data provider, and they used to be in a data center, but they migrated to AWS, and so now they're in a VPC. So how would I basically connect my corporate network to this third-party network, but they're in a VPC now, not a VPN and not some physical thing. And so this tends to be kind of a case where, there's a couple different designs you could do here. The one I chose for this slide was to create a separate core network, just because people like to treat these external networks as a separate thing with separate change control and separate everything. And so, yeah, you could put, vendor 1, vendor 2, vendor 3, et cetera, into separate segments, or you can put the acquisition into over here. You want to connect to other clouds, you can connect this into this. And then any VPC that needs access to these sort of special networks, you can connect it twice, essentially. Connect it to the corporate network as well as to this sort of external network. And you could do this all within the same Cloud WAN. Absolutely, you could. But some people just, again, like that sort of pure separation here. And it's interesting, even if they have a VPC or their own transit gateway, this model still works. And so it's kind of like connect how you want, when you want to these models. Because remember, I did say you can share a core network out via the account ID and not just within your AWS organization. And you can do that, I don't know, a couple hundred times. So this is going to scale pretty well. And yeah, so one thing people don't understand is you can connect one VPC to multiple Cloud WANs or a TGW and Cloud WAN at the same time, right? So there's no limitations there. Well, we have a limitation of a soft limit of 5, mostly because if you're connecting more than 5 Cloud WANs to a single VPC, I think we should talk. Not that it's necessarily a bad idea, but I can't draw a good idea of what that would look like quite yet. I have a couple ideas, but so if you need to do it, let us know. And so yeah, some of the FAQs here that we get. So now, yeah, we built a really cool network. It's multi-region, it's secure, It's doing all of our internet firewall stuff. It's doing our business partners. It's acting as our WAN. And yeah, we're network heroes here. So some of the questions I get, so the BGP, for example, is pretty simple. So if you're used to banging on a Cisco or Juniper device and having a million policy tables and all these things, like we don't have that yet. So essentially, there's no filtering and community support. It's just from route table to route table. It's going to copy everything. That's all the routes it learns from attachments is going to basically redistribute. The static routes don't get redistributed. You have to do that manually. So if you need the static route in multiple places, just do it in multiple places, essentially. In terms of limits and quotas, it's 5,000 attachments. I think that actually should say 10,000 routes. It's 5,000 attachments, but 10,000 routes. And then 20 segments. That's again, 20 segments is a fairly soft number. Just talk to us if you want to do more than that. But most of the time I do these designs with customers. By the time you get to 20, more than 20, it's usually like, oh, well, you could get rid of 100 segments if you just use isolated attachments mode and some of these kinds of things. We're in 17 regions. So right now we're everywhere except for Korea, Hong Kong, and Sao Paulo. Pretty much all the other regions we're operating in. Oh, except for GovCloud in China, the partition regions. Because the service has the word WAN in it, we get a lot of very traditional WAN questions like, hey, can I support DHCP-EF on QoS? The answer we have is not no, it's just we do things differently. So we do capacity management across our backbone and we aim for 0% packet loss. And we do a pretty good job at that. We just don't have like prioritized queuing for any given thing over the backbone. And as well as the SLAs are, for a VPC within the region, there's not SLAs for example, from Ireland to New York or something like that. So there's not like hard SLAs that you might get from a typical service provider. We do have full automation support. So we have Terraform support, Terraform, CloudFormation, CDK support even. So that's all out there and ready for people. We've already got people building with that stuff, even though we went GA two weeks ago. And so the other question I get, because I've been presenting on this for like 6 years, is like, all right, well, so what's the difference between Transit Gateway and this? When do I use one or the other? And so I can break that down a little bit real quick. So one, Transit Gateway is not going anywhere. Still love Transit Gateway. It's an awesome product. We've got everyone from the smallest companies to the largest companies, last 4 years building on that. So it's not going anywhere. We're building a roadmap on both. And so the way to think about it is, Transit Gateway is really, it's still the workhorse for a lot of things. I recognize that customers are skittish and network engineers are skittish about new services, right? So if you want something that's got a million references and a lot of customers are using, Transit Gateway. Cloud WAN is built under the hood with something very, 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 very similar to Transit Gateway. So we haven't gone and built new data plane mechanisms or anything. So you're still getting that reliability from those services, but the front end APIs and the management is going to be different. And importantly, it's, for example, AWS does that stuff for you, right? If you're running a 4-region Transit Gateway deployment and you want to add a 5th region, you're talking about like 30, 40 APIs to add a 5th region. It's one line of configuration in Cloud WAN. And so depending upon your use cases, like it could be a lot simpler in Cloud WAN, but if you've already built that automation and you like it, you can just keep using it with Transit Gateway. It's a lot of case for a lot of customers. I've also talked to some customers that go, yeah, we run our own automation and we're terrified of it. We don't want to run it anymore. And so if that's you might want to take a look at Cloud WAN as well. One of the things that is a little bit different on Cloud WAN is the ability to segment. So if you want to keep segmentation and sort of route table access across multiple TGWs or regions, that's one of the unique cases for Cloud WAN for you to do that with. But you don't have to choose one or the other, right? You can say like, hey, you know what, Cloud WAN is our corporate IT standard, but like the cowboys can use Transit Gateway. Or you know what, actually Transit Gateway is our corporate standard, but like for this self-service developer sandbox, we really want to use that built-in automation stuff, and we'll have a spoke of Cloud WAN there. So you don't have to choose one or the other. And you don't get double dinged on the data transfer. So if traffic goes from Transit Gateway to Cloud WAN or vice versa, you only pay one data processing charge. And so you don't get billed for both of them. Which means that you can kind of run that stuff for a while without paying like long-term costs on it. And then there's a couple things on Transit Gateway that aren't on Cloud WAN. Some of those they're not on there yet, and some of those they probably just won't come. So for example, like multicast gets really, really hairy whenever you try to develop in a global manner. So Transit Gateway is going to probably have multicast locally for much longer than you'd ever see on Cloud WAN, for example. That could change, but that's a good example of something you would use Transit Gateway for. And Direct Connect isn't currently supported on Cloud WAN yet. So if you need to do a lot of Direct Connect, you can either, again, transitively bring it through Transit Gateway or just use Transit Gateway for it. And so some of the interaction models we see between Transit Gateway and Cloud WAN look like this. One is this sort of brownfield thing of, we often see customers kind of choose their phases of architecture, like they were in VPC peering, and then they did Transit VPC, and then they did Transit Gateway, and now they're looking at like, what does version 4 of their architecture look like? And so version 3 might be Transit Gateway. And so in between version 3 and version 4, you might just keep this peering connection up and keep both running. You may keep Transit Gateway alive until those applications die off. Totally valid. But like I said, some people might go like, actually, I don't want 2 versions of my architecture running at the same time. I want to converge those, especially if it's quick. And so you can migrate if you wanted to. And then you've also got kind of like, I would say this is even right now pretty appealing for a lot of Transit Gateway customers, which is, hey, I just want dynamic routing between my TGWs. So I peer all my Transit Gateways to Cloud WAN once, and then it gets dynamic routing from all the other TGWs. And so it almost looks like a bit of like an MPLS cloud almost. Peer once, get my routes from everyone. And then, I think I could see that evolving over time to say that like, we want our centralized internet egress and ingress on the Cloud WAN. And maybe there's no VPCs there. VPCs always stay on Transit Gateway because, I don't know, we built that automation or whatever. But that's kind of like the federation model that we see, like particularly like large companies that have a lot of like sister and partial companies and ownerships and mergers and acquisitions. Like, okay, fine, all of you get your own TGWs, don't bother us, but when you come to the corporate network, you're gonna follow the Cloud WAN rules. And sort of seeing a lot more of that model as well. And so in terms of partners, we've got a whole bunch of folks that are working with us on Cloud WAN. So, we've got the SD-WAN folks here. So if you want to choose your favorite SD-WAN vendor, we'll work with them. We've also got the folks on the integration side of things. So one of the things we've seen is that like often like a CIO or sort of high-level person will be like, yeah, I don't want to buy contracts around the world anymore. This seems like a really great idea, but even just me walking through this presentation, that was like 9 phases of what we call network transformation. And so how would I go and kick this off with my team? How would I lead that? So a lot of these SIs listed here, that's their sweet spot. We've also got professional services internally at AWS that they're up to speed on this type of stuff too. So we've found that to be pretty helpful on these. We also have some case studies from some of the analysts that show that like, hey, over this many years, you save this much ROI and TCO, and it all sounds great, like all of them do. But we've got those papers that if that helps you get that kicked off as well. And so yeah, I would say, closing remarks here, which is like the use cases for Cloud WAN are really sort of like this sort of self-service IT model, this multi-region networking, branch offices and SD-WAN and building your backbone with us. Any of these sort of like extranets and communicating outside of typical AWS type stuff. And then together, they work better together. Transit Gateway and Cloud WAN are good friends. And so they can be forever together, migration or federation. So there's a lot of models there. So thanks everyone for coming. I pressed the wrong button. Thanks everyone for coming. I know you guys have a party to get to and everything. So I'll be up here for questions if anyone, and submit your feedbacks and let me know what you want to see next time. So thanks everybody.